Good afternoon, everyone. My name is Elias Haddad. I'm a product manager at Splunk, responsible for data collection. A little bit about me. I joined Splunk actually a little bit less than 4 years ago. And I fell in love with this piece of software since I first put my hands onto it. The topic of our conversation today is Splunk, obviously, but also an exciting new announcement around Splunk. I'm not going to spoil the surprise, but I'll give you a hint just to whet your appetite. It's about Kinesis and Splunk. So this is the agenda. For those of us who are not familiar with Splunk, I'll go over what Splunk is. I promise I won't be too long on that front, just for us to focus on the announcement. And then we'll talk about the ingestion landscape at Splunk, some of the challenges that we have, and how we're going to plan, or how we're planning on addressing these challenges by leveraging that new ingestion mechanism that we have with AWS. And then at the very end, we have Steven here from Cox Auto. He's going to talk about some exciting use cases that Cox Auto has built around Splunk and AWS. For any questions that you might have, please leave it till the very end so that we'll dedicate around 10 minutes or 15 minutes for that. So over the course of the session, I have to go through this. We're going to make forward-looking statements. These are based on current facts and current events. Would like to caution you that some of these facts might be different in the future, so things might change when things happen in the future. So just a quick question, show of hand. How many of you are familiar with what Splunk is or our current? Oh, wow. Okay, maybe I can skip all the slides then. So I'll skip through it real quick. Just to introduce what Splunk is. So for us to understand what Splunk is, we need to understand what machine data is. And machine data is any type of digital exhaust that gets generated by whatever powers your organization. And that can be very broad in nature. Machine data is growing fast, and which adds to the complexity of getting insight into machine data. So as you see here on the slide, machine data can be broad range of things, broad range of data sources. What you see here is just a small subset of what you can get into Splunk. For example, if you're an airline company, this could mean machine data generated by application logs, by events and metrics coming from your application. Could be events coming from the infrastructure that's hosting these applications. Could be security data coming from firewall, network devices, and so forth. Also, could be way beyond this, any Twitter feed, any social media interaction for you to get insight into how well your customers are interacting with your application. Also beyond that, it could be in the Internet of Things world, it could be sensors, whether it's airplane or train and so forth. So with machine data, there's a lot of complexity. So we believe that machine data has a lot of value, and I'm sure you guys believe the same way, but also it's very messy and unpredictable. It's very hard to extract and harness that value from machine data. It's also, for you to get insight, you need to swift through massive amounts of data, which makes it even more complex. So you need something that scales to the volume and to your high number of devices that are generating these machine data. And most importantly, you don't necessarily know the question that you want to ask this data up front. So with Splunk, you'll have the ability to ingest all that data regardless of the format, regardless of where they reside, and then you can ask the question based on your needs. So what is Splunk? Which brings me back to what Splunk is. It's a single piece of software. It's one platform. It allows you to ingest, analyze, and visualize machine data in real time. That's pretty much in a nutshell. It has the ability to analyze that data at scale and reliably and in near real time. It's an open ecosystem, meaning that as a platform, you'll have the ability to build your own data ingestion, but also build your own visualization do your own customization to get insight into that data. It's a very open ecosystem. We have a broad range of apps on our app store, so it's a very vibrant ecosystem. An app in Splunk is nothing more than canned visualization that targets specific use cases or specific technology, just like AWS, for example, one of our more popular apps, Splunk app for AWS. So we have various apps that you can download from our app store, but also you can build your own. It's a very extensible platform. One thing worth mentioning is that Splunk is hybrid, meaning that you have the ability to ingest data from on-prem, cloud, and various cloud vendors as well. It's a machine learning powered platform, which means not only you have the ability to get insight into that data, but also you'll be able to apply machine learning to be more proactive into how you would look into that data and how you analyze the data and how you would detect anomalies whenever something deviates from the norm. That's our mission statement: make machine data accessible, usable, valuable to everyone. We have a high number of customers, over 13,000 today, worldwide, highly mature piece of software. So let's talk about Splunk and AWS. So we have, over the past year since I joined Splunk, there's various points of synergy between the two companies, between Splunk and AWS. And this can summarize a little bit our point of synergy. So today you have the ability to use Splunk Enterprise, which is the piece of software that you can download and deploy it on your laptop, but also it's available for you as an AMI to request it from AWS Marketplace. Also, you have the ability to use Splunk Cloud as a service, which is Splunk Enterprise as a service. Also, we have two apps that are available for you. One is the Splunk app for AWS that gives you quick insight and quick visualization against various use cases with AWS, whether it's billing, managing your billing and cost, whether it's security use cases around visualizing all the activities around your AWS services, or whether it's IT operation related type of use cases measuring performance, and various infrastructure management type of use cases. And also we have a broad range of integration, and this is pretty much the focus of our topic today, is to cover the data ingestion part. So we have the Splunk add-on for AWS. We'll talk about that in more details later on. We also have Lambda Blueprint. All of this has a very broad range of support against pretty much all the AWS services. So you have the ability to ingest pretty much any data from any service in AWS. The culmination of our partnership is Splunk Cloud, which runs on AWS. So if you're not a customer today, you have the ability to request it, to request Splunk Cloud from the region that you would like to have. With that, this brings us to the main topic of our conversation today, which is the data ingestion landscape from AWS. This is one of my favorite slides on this deck. The guy who built it is probably not here, but this summarizes pretty much everything you can ingest from AWS. As you can see at the top of the slide, you have all the AWS services, whether it is CloudWatch config, CloudWatch events, CloudWatch logs, IoT, Kinesis, and so forth. It's a very broad range of support that we have today. And this summarizes as well the mechanism that you have today to ingest that data from into Splunk. So one mechanism is DB Connect. Any one of you familiar with DB Connect? Okay. So DB Connect gives you that ability to query databases directly, ingest the data, or query the data directly from that database. So whether you have Redshift or any other database, RTS, running in AWS, you have the ability to ingest that data. The Splunk add-on for AWS, which is the more popular type of data ingestion mechanism, the way it works is it's a poll-based data ingestion, meaning you have a script that runs on the Splunk side that periodically queries the APIs from the various AWS services, and this script keeps querying and ingesting the data and keep track of where it last left. So this has a very broad support as well. And then also if you want to push the data into Splunk versus the pull of the AWS add-on, you can use Lambda today. We have various blueprints that support a wide range of services as well. So we have push and pull and query from the database. But the main point behind this slide is that it is a little bit complex. So we have good support, but however, it becomes a little bit complex for you as to what type of mechanism would you use to ingest the data. And this is one of the challenges that I see today. But there's more than that. So we have some of the reliability, scalability issues, managing the data collection nodes. It is doable to be reliable. It is possible to be reliable and scalable today, but it's not easy to manage, and that's one of the challenges that I'm highlighting here. The other part is managing data collection fleet, or what we call in the Splunk word modular input, which typically comes with the add-on. There's a management overhead. There's some complexity behind that to scale out and manage all those data collection nodes. Something that's not necessarily related to the add-on itself or the data collection itself, there's delayed event. And this is very common. We've seen not necessarily with AWS, but also with other third-party APIs that we integrate with. Whenever you do pull-based ingestion, the events are delayed. And we know and understand that everybody wants real time. Delayed events are not ideal in many of the security use cases and IT operation use cases. Very common, very problematic also is the API throttling. I don't know how many of you are using the AWS add-on, but there is limit on the AWS APIs, and we constantly hear from customers who use it that they're hitting those APIs and they keep pumping up that limit. It's nothing we can control, but it's pretty much on the AWS side that we constantly hit, which results in a lot of data loss and frustration also from the customer side. So with that, we need a new solution. And today what we're going to announce is a new solution that both Splunk and AWS, very happy, very excited to announce. And that's why we have Ray. It's a solution that both teams have worked on, collaborated on, a lot of effort spent in there. And then, Ray, I'll let you take over.
All right, thank you, Elias. Can you turn the microphone on? Can you guys hear me well?
No, I don't think so.
Okay, I'll just try to get out of the microphone. So, thanks for coming, guys. Good afternoon. Super excited to be here. My name's Ray. I do product management for Amazon. I'm the guy that brings in the new solution for you today. So I work for Amazon Kinesis. Amazon Kinesis is real-time streaming data service platform at AWS. So before I kick off, can I have a quick show of hands? How many of you guys have heard of Kinesis before? Great, awesome. Almost every one of you guys. How many of you guys use Kinesis today? Good handful. Great, awesome. So today we have 3 services under the Amazon Kinesis brand. On the very right-hand side, that's the first service we shipped about 3.5 years ago. It's called Kinesis Streams. It stores the data in real time and stores that in a replayable streaming manner to enable you to run your own applications. The early motivation for this service actually from the internal demand from AWS. You guys are AWS customers. You guys use EC2 instances, S3, Redshift, database. And most of these services have pay-as-you-go pricing model, which means for every second, every minute, when all these millions of AWS customers using these services, all these services are running metering data to meter how many usage of the particular service you have been using. And it's a huge problem to solve because number one, it needs to be in real time so that you can see your estimated bill sooner than later. Number two, it has to be able to be highly available, reliable, and scalable because all these AWS services and instances and servers are talking to this service. That's when we invented Kinesis Streams. So today, the entire AWS metering and billing pipeline runs on Kinesis Streams. So since we shipped the service, we see a lot of creative real-time use cases coming out from our customers. And one of the top use cases actually customers would like to use the tools and analytical solutions they've been using for things like Hive, Presto, a data warehouse, a visualization BI tool, or a search engine, or Splunk. So they actually built these applications to ingest these real-time data from Kinesis into these different places. Then we figured actually maybe we can do something to make these use cases a little bit easier, which is when we shipped Kinesis Firehose. It's an abstraction layer built on top of Kinesis Streams where it does manage data delivery into these different destinations, including storage and analysis destinations. We support S3, Redshift at the initial launch, and later on we added Elasticsearch. This service is serverless, which means you do not need to manage any server. It scales elastically. You just keep pushing the data into the service, scale up and scale down. You do not need to worry about it. Has a pretty elastic pricing model. You only pay for the data volume gets transferred through the service. So you don't pay anything if the volume is not there. And you pay low volume when you have low traffic volume. You pay high volume when you're at the peak. So that's the Kinesis Firehose service, loading data into different data storage and analytical destinations. Then we ship the third service called Kinesis Analytics. It's a SQL engine that allows you to using SQL skill to query and analyze the data against a real-time data stream. So once we ship these Kinesis streams and Firehose service, we see a lot of demand. Customer wants to run real-time analytics and applications. However, writing a distributed system dealing with real time isn't super easy. Not a lot of customers have that skill set yet. So we ship this service to let customers using standard SQL, which is a skill set vast majority of the technical professionals has today. So anybody who can write a standard SQL, now you can using SQL to query against live stream to get insights, run real-time dashboard out of your data with minutes or even seconds latency. And today, you probably have guessed, the main service I'm going to talk about is the Kinesis Firehose service, real-time ingestion service. So this is how Kinesis Firehose looked like before. It has three major components. Number one is data ingestion. You got to have to get the data into the service, continuously pushing data into that in real time. So there are a few mechanisms for you to get data into the service. We offer two RESTful APIs. So virtually any device or service can put AWS SDK on it. You can use the API to get data into the service. We also offer a Kinesis agent. It's a Java application for you to install on Linux instances or servers. It monitors a local log file. As new data gets written into the log file, it'll pick up and forward that into the Firehose service. It also has native integrations with a bunch of AWS native services, for example, CloudWatch logs, which means you can hook up a Firehose delivery stream with CloudWatch logs to pipe your VPC flow log, AWS Lambda log, or any of the log that you ingest into CloudWatch log in real time into the service. We have integration with CloudWatch events, and that service has a lot of interesting changing events generated by AWS service, including CloudTrail, EC2 change events, S3 events. You can also hook up a CloudWatch event topic with the Firehose from the console with a few clicks. You can stream these CloudTrail data, for example, into Firehose in real time. We also have integration with AWS IoT. For those of you guys have IoT use case, AWS IoT is integrated with Kinesis Firehose directly. So you can have your IoT device using MQTT protocol, super efficient for low compute devices to talk to the AWS service, AWS IoT service to get data off your IoT device in real time, push that into Kinesis Firehose. And I believe last week, AWS IoT just announced the new pricing model. So in the case when you just use MQTT protocol to push data from IoT to Kinesis Firehose, you pay a much lower cost than you used to do. So super exciting. The middle level, it's a transformation feature. So a lot of the time, the data is generating a raw format. It's not suitable for analysis out of the box. But people don't want to have a multiple stage layer for you to get the data into the system, have another system to do transformation, and another system to do analysis. So Firehose is integrated with AWS Lambda for you to specify a custom function to do data transformation on the fly as the data is transferred through the Firehose service. So you have a serverless pipeline to do ingestion, transformation, and delivery. And delivery is the last piece. As I mentioned, we start the service with S3 and Redshift as the supported destination. We added Elasticsearch later on, and you probably have guessed, today I'm super excited to announce that actually Splunk is going to be added as an addition to this graph. So we heard a lot from our customers since we shipped the Firehose service. They would like to use Splunk because Splunk is super popular, super easy to use tool for you to analyze a lot of the machine-generated data. So we heard from our customers saying, we want to use Splunk. Can you guys support Splunk as a delivery destination? We also want to take advantage of the real-time ingestion capability from Firehose. So we started a conversation with Team Splunk, and they also heard a lot of feedback from their customers because we have a lot of the shared customer base. They're looking for a reliable ingestion solution to get data into Splunk. So we thought it made a lot of sense for us to do a solution to do an integration between Firehose and Splunk service. So we started working on this project. And a few months back, we announced the beta program for this integration at Splunk.com conference. It was super well received. We got a lot of beta customers sign up, help us testing. And at AWS reInvent this week, this feature is now generally available. So if you go to AWS console, go to the Kinesis Firehose service console, now you can see a drop down with Splunk as an addition to get data from Firehose into Splunk in real time. So why is this important, and how does that solve the problem Alice just mentioned previously? Reliability, scalability, and fault tolerance. As I mentioned, the entire idea of Kinesis service, including Firehose, is built based on the need of AWS metering. So it has to be highly available, reliable, and scalable to handle all these mission-critical data to run the entire AWS cloud. So Firehose has that capability. For all the data we receive from you, whatever data source or your service or mobile devices, we automatically back up your data across 3 different AZs, data centers. And we very simple, we just don't lose any customer data. Since we started service from 3.5 years ago, since I joined the company, we did not lose a single byte of customer data. So once we send the data into the Kinesis service, we don't lose it. We durably store that. Second is management overhead for data collection nodes. Like oftentimes, you got to have to run an ingestion fleet to handle data volume from different places. As you scale, you have to figure out a way to add instance, add storage nodes, add memory. It's super painful and not cost effective because you have to plan for the peak and over provision on your infrastructure. But again, as I mentioned, a Firehose is completely serverless, and you do not need to think about any resource, and the pricing model is completely elastic. So you will not overpay because you need to provision for the peak. There's nothing like that. Also, delayed event delivery due to pull-based ingestion. So from Firehose, we use a push mechanism, leveraging Splunk's HTTP event collector. So we actually use a pushing-based mechanism to get data into Splunk. And we also have a data backup feature. So for any case when the network has a disruption, or you are doing maintenance on your Splunk cluster, or you're resizing your Splunk cluster, we can durably back up the data into an S3 bucket that you own, so that later on you can backfill. Again, that's for high availability and data durability. And also API throttling. The reason is because using pull-based mechanism with Splunk add-on to get data from AWS services into the Splunk cluster, a lot of time you have throttling limit to get data out of these services. In the case of Firehose, we use a push-based mechanism, so you no longer need to worry about that because we deal with these throttling mechanisms by direct integration between Firehose and all these other AWS services. And down the road, you should expect to see a lot more direct integration of AWS service logs, including any other data with Kinesis Firehose out of the box. So you can just wire any AWS log data or server event data you want to analyze, including metric data you want to analyze using Splunk. You can just go to Firehose console and hook them up. It'll probably take like a few minutes, then you have the real-time pipeline running. So that given said, I'm super excited about it. Since you guys, most of you guys have heard of Kinesis, I highly encourage you guys, after this talk, when you get a chance, go ahead and log on to the Kinesis Firehose console, enable HEC token on your Splunk cluster, try to ingest a few events from the delivery stream from Firehose into Splunk, and see these data in motion, leveraging Splunk's real-time dashboard and search capability, leveraging Kinesis Firehose real-time ingestion capability with fault tolerance and reliability to see what are the powerful tools and capabilities these two services can bring to you guys together. So given that, I'll hand it back to Alice to talk a little bit about the advantage for using Kinesis Firehose.
Thanks, Ray. So in summary, why use Kinesis Firehose? With Splunk, it's fully managed, so you don't have to manage your data collection fleet. You don't have to manage your data collection node. One cool thing about this integration is that it simplifies the architecture, basically. It bypasses the need to have heavyweight forwarded tier in the middle. So that's still an option for you for various architectural consideration. However, this is not really required anymore. So you can stream the data directly from the AWS console straight into your Splunk indexer. It has greater reliability, greater scalability as well, of course, just like we mentioned early on. It's well integrated with various native AWS sources, whether it's CloudWatch Event, CloudWatch Logs, VPC Flow Logs, and Kinesis and AWS IoT. So these are native, pretty much, integrations. You don't need to do any programming and write any code. It's pretty much out of the box. All you have to do is take the HTTP event collector IP address and the token, paste it on the AWS console, pretty straightforward, and off you go with streaming the data directly to Splunk. It also has the ability to extend and transform the data, so you can invoke Lambda on any data that you're streaming to Splunk. A good use case for this, if you want to normalize the data before you index it, that's one option that you have for you. It's relatively low cost. This is what you see on the screen is, I think, the higher tier. There's different tiers, but in general, it's low cost for ingesting that data into Splunk. So let's talk a little bit more about the architecture. How does it work? So on the left-hand side, you have the AWS side. You have in the middle the AWS console. Kinesis Firehose has native integration with CloudWatch Logs, CloudWatch Events, and AWS IoT as of today. There could be more in the future, something Ray can cover if you have any questions. However, this architecture is scalable. It does load balance the data. Typically, you would want to put a load balance in the middle between your AWS environment and Splunk. Basically, you put the load balancer right in front of your indexer. As I mentioned early on, this is a simplified architecture. Doesn't mean that this is the only architecture that we support. So you would load balance the data to your indexer tier directly. One powerful thing about this architecture is that it leverages HTTP event collector indexer acknowledgement. So for those of you who are not familiar with HTTP event collector, it's an HTTP listener that Splunk provides you. It's highly scalable, highly available. It's basically listening on HTTP port, waiting for events to come in. AWS Firehose directly stream to your HTTP event collector. If you want to scale out, you can add as many HTTP event collector nodes as you need, as long as you put that load balancer in front. One thing also worth mentioning, HTTP event collector has indexer acknowledgement. What this means is that within Firehose, when you send the data, if let's say the data didn't get indexed, Firehose checks that the data is indexed, and if it didn't get indexed, it can write it to S3 bucket, and we'll talk a little bit more about that. But basically, you're doing guaranteed delivery by leveraging that integration and leveraging the indexer acknowledgement. So this is, if you want to scale out, how you do it, you add as many indexer and as many HTTP event collector nodes, and you put a load balancer in the middle. How do you achieve reliability? Like I said, if let's say Firehose streaming the data, you have some network outage, or you have Splunk is not reachable for one reason or the other, Firehose buffers the data for a certain amount of time until eventually, if Splunk is still not reachable, you can persist the data onto S3. So it has back pressure relief to start persisting the data into an S3 bucket that you can configure as part of your configuration process. Now, once the data is in S3, you have various mechanisms to get it back into Splunk. One mechanism is to use a hybrid push and pull mechanism. So what this means is that you can use the AWS add-on to ingest that data directly back from S3, from that bucket that you configured for the failed event. So that means you have a hybrid architecture, and it is less prone for failure because now you're having hybrid push and pull. The other alternative to this is once the data is in S3, you can use a purely serverless architecture. As opposed to using the add-on to ingest or pull the data from the S3 bucket, you can leverage Lambda to stream the data directly from S3 as soon as S3 receives those events into HTTP event collector. Obviously, because you have basically both push mechanism directly from Firehose and S3, you might want to configure your Lambda to stream the data into a backup Splunk environment, because you don't want to overload your Splunk environment if there's a failure or there's a network outage. So it makes sense to get the data from S3 into a separate Splunk cluster. But in this architecture, it's purely serverless. You don't need to have heavyweight forwarder in the middle. So that's an option. That's a consideration that you can have based on your requirement. Very popular. We've had a decent amount of customers who were part of our beta program. And this is pretty much a request that we got from everyone, and we get every day from a data ingestion perspective into Splunk. Very popular request. A lot of customers want to ingest data from multiple AWS accounts. And this is basically the power of Splunk, the ability to get insight into data sources across a broad range of AWS accounts. So in this slide here, you have VPC flow logs as an example, but doesn't have to apply for VPC flow logs. It can apply to CloudWatch events and other. But the idea here is that you want to ingest from multiple AWS accounts, but you don't want to necessarily configure Firehose from each individual one. You don't want to go through the management overhead of configuring Firehose on each individual account. So in this case, CloudWatch logs natively has the ability to consolidate into one account. So you stream the data from CloudWatch logs into one single account. And then from there, you want to get the data into Splunk using one Kinesis stream. But here lies the challenge, is that most of the use cases that we've seen with customers rely on the fact that you want to control access. You want to have access control over the data. You don't want to give access to account A. If data is coming from account A, you don't want to give access to that data to the users for account B. So obviously here you want to resegregate the data in Splunk. Typically the way you do it in Splunk is segregate the data based on index. And this is where you can leverage the power of Lambda transformation, where you can put conditions to override the index before you send it to Splunk. So in this case, every account data would get segregated and goes into separate index. And then from there, you can do the access control, and you can build your data retention policies based on the various indexes that you have. So in summary, this is our new landscape. You still have the various mechanisms. We've enriched it with Kinesis Firehose. You can still use the AWS add-on for ingesting data from S3 and the AWS services that are not supported by Firehose. You still have the option to go push and pull. We give you that flexibility to architect your Splunk deployment and your data ingestion based on your needs and your own requirements. But we have a very broad and rich data ingestion mechanism today. And with Firehose, you have very powerful, scalable capabilities as well. Before I hand it over to Stephen, worth mentioning today, if you want to, this is generally available, so feel free to try it out. It's available on the AWS console. On the Splunk side, it is available for Splunk Cloud and Splunk Enterprise. Everything is available. You can also download the Splunk add-on for Kinesis Firehose to apply knowledge on the data that you ingest from Kinesis Firehose. Feel free to download it from Splunk Base as well. So, and we have a demo booth if you want to check us out. So with that, I'll hand it over to Stephen to talk about some exciting use cases.
Thanks, sir.
Thank you.
Good afternoon. All right, how you doing? My name is Stephen Hatch. I'm from Cox Automotive, based out of Atlanta, Georgia. I see a lot of folks here from our Cox Automotive, folks from Earthlink from 12 years ago. I see you. I'm very honored to be here today to speak at the AWS reInvent Conference of 2017. I I would like to thank Splunk for this big picture of my dome. There's some context to this picture. My boss is also in the crowd. It was my idea actually to get a video success story on a use case of Splunk. What I didn't realize is the cameras that Splunk brought also have the 4K cameras with pick up every little subtle sound. So unfortunately, in the middle of June in Atlanta, it was 96 degrees and we had to turn the air conditioners off because they were too loud. So what you don't see, unless you zoom in, there are the beads of sweat at the top of that dome there. And just to let you know, and of course, that blue long sleeve fleece that I decided to wear, someone told me that it pops when you're taking a video or pictures. But that's just to give you some context there. So that smile you see, that's really, please, let's get this right. All right, so as you see there, 20 years of IT experience. I am the manager of the Enterprise Login Services group at Cox Automotive. The metrics you see there on the bottom, Cox Automotive, 24,000 employees worldwide. They are not all here today. You see the 40,000 sales and all the way across, but the biggest number there is the far right, is that 67% of all car buyers. So basically, you've seen the commercials for Auto Trader and Kelley Blue Book. So for any cars that are pretty much bought, 2/3 leverage our services. It's an impressive number. And the vision of Cox Automotive is to transform the way the world buys, sells, and owns cars. All right, here we go. So this slide here, it represents the life cycle of a car. As the manufacturers, domestic and international, produce the cars, they're then distributed to the dealers to be sold. Cox Automotive had a vision. That vision is, well, why not own the entire life cycle? Well, how do we do that? Well, let's go ahead and find the services either by way of homegrown or acquisition or merger. We teamed up with all these different companies to produce this entire life cycle. So whether you're on the right hemisphere there with the dealers or the left hemisphere, the consumers, we pretty much have a service for every facet of this life cycle. So as part of this use case, I want to talk to you about Mannheim specifically. Mannheim is the auto auction company across the United States, 84 plus locations, that facilitates the sales of dealer-to-dealer auctions. It's a little different than consumer type that we can go to. This is, again, dealer-to-dealer. So this is the auction in the Bay Area off of 880 for those that are aware. 8 lanes that are basically going in parallel. All makes, all models. People are there to physically kick and touch the tires, make sure that's exactly the car they want to fulfill their demands. Some have a surplus of this and a lack of that, so that's why they're there. They're here to trade their inventories. As we go into the lanes, you'll see there are people in action. And if I slip to the next one, there it is. This is the inside view of, again, one of many auctions. We have some as many as 32 lanes that happen in parallel. So again, there are guys there in the lanes. You see the silver card on the left. The hood is actually ajar, if you will, because some people actually go up there and lift the hood to actually look to see if there's any oil leaks, transmission leaks, power steering, all that kind of stuff. They're pretty thorough. But what I want you to pay attention to is what's on that wall there, that TV screen. That TV screen depicts the actual car that's in lane right now being auctioned off. And all the different makes, models, the year, the VIN, all that good stuff. But there's a key metric on this slide that makes this thing really exciting. It's the number of online bidders. That means for this particular lane, this particular auction, for this particular car, there are 12 people somewhere on the internet also bidding in real time for this particular Volvo. All right? So you see the 3 guys there on the bottom. The guy on the left, that is what we call the clerk. He's the guy that ups the price every time the auctioneer goes through his audible. The auctioneer is in the middle. The guy with the dome, that's the actual dealer or the representative of a dealer with the pink slips in hand. So that's why he has the most concerned look, because he wants to make sure not only do all his cars sell, but for the price that he wants, right? Because he has to make his money. So to make that happen, There are gentlemen in this room that helped set up this infrastructure. We have high definition cameras for every lane across all of our auctions. So basically, we throw back all the way to our data centers and mirror that up with the data that have those metrics, so that the users, by way of their cell phone, their smart devices, their laptops, their desktops, can bid against the people in real time for these cars. All right, so now, with all that being said, I want you to pretend this is a AWS Lab real quick. I need you to put your scripting hats on. Audio, video, network gear, and monitoring. You're now being tasked to monitor the health and wellness of this system. So let's start off small. Let's just talk about one lane. So first, the component is the users that want to connect by way of the internet to connect to the stream. That stream could be a data center or it can be an AWS. On the other end, again, is that single lane. We have to keep in mind and take in consideration the audio and video, the metrics that are coming back and forth when the auctioneer is upping and incrementing the price, all right? All that gets mirrored up in real time for the people to leverage and make a sound decision on buying that car. We need to protect that. So I need you to write a script, whatever tool, whatever language, whatever service, to make sure that that system right there stays up. Is that too big of a deal? For some of you, it's probably real simple script. What if I ask you to expand that to 3 lanes? All right, for loop, array, whatever the case, right? Not a big deal. But remember, I need you to own this for a little while as a prototype to see if this thing works. Weeks go by, days go by, it works out pretty well. The way things work, people say, you know what, I heard this guy wrote the script and he's protecting 3 of your lanes. I want the same thing. Because remember, I have 84 auctions to consider. So now, let's say you're based in Atlanta, Georgia. Your script is getting more and more press. Not only is it now monitoring all the lanes at a particular auction, the whole East Coast wants it. All right, you expand your script some more. You get some more resiliency in there, a little bit more efficient, and it's working great. Remember, you need to own this. 9 to 5, sales, start and close. I need you to be aware of it. Well, guess what? The folks in the Midwest hear about it. The folks on the West Coast hear about it. So remember, I need you to own it. 9 to 5 in the West Coast is what time on the East Coast? 8 p.m. I need you to own it. So are you going to stay around till 8 p.m. every day, 5 days a week, for every auction, for every lane? 84 auctions, let's say 8 lanes per. That's a lot for you to be responsible for. So I'm thinking you're going to be smart and you want to leverage an application of some sort to do all this automation for you. And so maybe you buy some third-party app and it worked out okay. So whatever the visualization is that this third-party app provided, you leverage for a while, but over time, it still became too overwhelming. So then, you know what? Because this app, maybe it did work, but I need someone to handle all the influx that's coming my way. Because remember, I got to protect cameras. I got to protect microphone audio. I got to protect a specific switch for a specific auction that represents a specific lane. And then at the same time, I need to give specific ammunition to a network operations center exactly what the problem is. I can't just simply say simulcast is down. I need more information than that. Which auction, which lane, which component, what is down? Talk to me. Describe, use your words, right? Well, because of the app that you did, maybe it is giving you this information, but it's giving me too much at the same time. So if, say, Pennsylvania goes down because their internet pipe went down, does that mean the camera's down? Is the lane down? No. The internet pipe that allows the traffic to come all the way back and mirror up the data, that's been broken. So the people on site, they don't know it. And frankly, they don't care, especially the guys there in lane, because that's less competition they got to worry about for that period of time. Whoever gets cut off on the internet, yes, we don't make the money we want, but the guys in the auction are actually kind of happy about it for a period of time. So all this needs to be protected, monitored, and accurately, if you will, demonstrated to the NOC to say, look, I need to know exactly what's going on so that way I'm getting the right people engaged. If I tell the guy to run up and down 32 lanes to check his cameras, and it's just one lane that's down, that's not efficient. If all the lanes are up, but it's the internet pipe, I need to tell him to call, or the network team to call the service provider, not to have my guy run up and down the lanes trying to fix things, pulling out plugs to fix one lane, and now he affected another auction lane. So we then graduate and went to Splunk. We said, you know what, let's get all this data in the Splunk cloud. Let's get some more intuitiveness. Let's get some more proactiveness and leverage the components of Splunk cloud as far as ingesting all that data, correlate the events, making sure that I can say, you know what, if this A, B, and C happens, then I call this person. If it's only B and C, then I only call this person. But I'm not going to wake up everybody for every lane. And then maybe over time I could take advantage of the fact that I have the schedule in a database. So if an auction component goes down on the West Coast and it's a Saturday, am I going to give it the same urgency if there are no sales going on? Or if an auction is already concluded, yes, I'll notify someone, but I don't need to raise as much cane until it gets closer to that schedule. And I can actually leverage time to say, you know what, an hour before, let's get a little bit more, let's intensify the notifications. So correlation gives me those abilities. And again, alert routing, give it to the right person. And then, but when it comes down to this, Splunk Cloud alone or Splunk Enterprise can't give me that type of anomaly detection that I want to look at the data as a whole. Maybe there's no problems going on, but there's something in the data that has changed, but it hasn't impacted the service yet. It might be right there at the threshold, waiting to raise its ugly head, probably on a Wednesday at the prime time of our biggest sales, and that's when we exceed the bandwidth. So that's why anomaly detection would be a good thing, and that's why ITSI is the next step. The metrics that we have in here, and as you see there on the left-hand side, these are the actual KPIs that we measure for the traffic that gets sent back. And so the top is your service health score, and whether it's packet loss, which you see is all over the place a little bit, jitter, audio silence, flapping, packet ordering, all of these are metrics that represent the overall health score. So any one of these are out of norm by way of ITSI and its machine learning and anomaly detection. It can let us know that, hey, I'm not going to tell you which line of code or what exactly is wrong, but I'm telling you something has changed. And I can go back in time and look at, oh, there was a release on this time, or there was a maintenance by Sprint or CenturyLink or somebody else. Let's go back and investigate what actually changed instead of waiting for it to impact us. And then again, by way of the default service analyzer, you can get that kind of view, and that way people can see this thing all across the room, understand that red is bad and green is good. And when that specific KPI is satisfied, then everything will render green and we're back to where we need to be. I want to pivot real quick and talk about our expansion of self-service at Cox Automotive, where we basically have allowed a lot of our DevOps teams to leverage Splunk Cloud specifically, to help accelerate their continuous delivery in their pipelines of getting data out. So we try to extend our service by way of GitHub and getting a lot of our binaries and configs out there where they can ingest them and leverage them by way of automation and not have to worry about submitting requests or emails and stuff like that. So whatever automation they want to leverage, that's their choice by way of revision control, leveraging the deployment server or not, that's their choice. So however way they want to cook their meat, whatever they want to leverage, a smoker, grill, charcoal, whatever, I can care less. If they're happy, I'm happy. Center of Excellence. One thing going on 2.5 years now of managing this service, the one thing I would put out there for anyone that's leveraging or managing Splunk is to make sure you build the relationships, especially on the enterprise side where you don't own the storage or the virtualization, you don't own the network gear. You may have different partners or business units you may have to consider and talk to. There's a lot of talking, there's a lot of establishment of standards, which is basically the second bullet point. You have to make sure you have something consistent out there so you can support it. If everyone runs on their own different versions and want to leverage the deployment server in a certain manner or want access to your deployment server, you're gonna have problems. Again, standardize on infrastructure. One thing I love to talk about is empowerment. By empowering my users, who are my most important resource, by empowering them, I get that by way of education. The more I educate them, the more then they can be delegated to as far as knowledge managers to help my team to get more done. So the more they're skilled, the more they're educated on proper SPL, best practices, tags and whatnot, the better experience it is for everybody. Evangelizing, like I'm doing right now, is to get out there and spread the word on best practices and reiterate some of the things as far as technical debt and stuff like that to make sure people understand that we have to protect the platform and make sure that we're all good stewards of this powerful search tool. Build for scale, obviously things change and you have to make sure you're always looking over the horizon to make sure that whatever you thought was good last year may not be good this year. Always go back, revisit, do your retros, look at everything that you set up, look at your documentation, how dated is it, and as far as your partnerships with your resources, again, your virtualization team, your storage teams, let them know that, hey, we forecast this, so I may need a specific number of VMs or memory or resources or storage, what have you. Don't put them in the dark and then at the last minute request something and then they don't have the budget to support you. And then part of that is just growing your business. Grow it, market it, evangelize, teach, be available. A lot of things to do to support Splunk other than SPL. So before I conclude, I would like to kind of talk about very briefly as far as the announcement of a Kinesis Firehose. We are in the beta mode right now at Cox Automotive, so we have not committed to anything. However, in my case, probably one thing I could think of that might be a good use case of it is the devices themselves for simulcast. That might be a nice way to go directly into Firehose opposed to going all the way to the web server. The web server writes the law, the universal forwarder picks it up, sends it to Splunk Cloud, then gets indexed and gets waited to be, or then waits to be ingested. Maybe that might be something that we could leverage in the future. Again, it's beta, and again, we're not committing, but that's something that we may consider. Thank you very much. Any questions?
Yeah.
It pretty much worked for both.
So I'll repeat the question first.
Yeah.
The question is, does the Firehose integration with Splunk only supports AWS, based Splunk Cloud or any other? So in this case, it supports any Splunk version as long as you can enable HEC token on it. So it could be Splunk Enterprise run on EC2 instances. It could be Splunk Cloud. It could be using Splunk Enterprise running on-prem servers.
As long as it's the right version, which is 6.5 and above. Say that again?
So the Splunk forwarder that you install on the machine,
Uh-huh.
does this have anything to do with its future? Is it going to be around, kept around?
The question is the Splunk forwarder going to be kept around? For now, it is. I mean, in the case of AWS, one way of ingesting the data is using Firehose. You would still need the universal forwarder or the heavyweight forwarder for other use cases, whether it's ingesting data from your on-prem devices or whether running add-on, because there's a lot of other APIs that you might want to ingest data from. So in this case, it's still around.
So if we want to pull like OS performance metrics from AWS, can we use it with Firehose or do we need to use Splunk forwarders?
Yeah, so the question is, if we want to pull OS performance metrics, I suppose from EC2 instances and use Splunk to analyze, can I use Firehose? So the short answer is yes. So all these metrics you can emit into CloudWatch metrics, then probably use a forwarding mechanism like Lambda function to pull these metrics out of CloudWatch metrics, forward that into Firehose, and we can ingest into Splunk. You probably know from the .conf, Elias can talk more. Splunk just added some very amazing capability for metric analysis. So, but as I mentioned, down the road, we kind of want to make this integration really easy. So we've heard repeatedly from the customers who want to use Splunk to analyze metric data. So we do have something on the roadmap. Can share about timeline to have a direct integration between CloudWatch metrics and Firehose. So you can basically have your OS metric data or any metric data from your EC2 instances gets written into CloudWatch metrics. It'll stream into Firehose directly. But today, you're going to have to use a function or instance to do the forwarding.
Follow-up question. So do you think we still have a need for deployment servers in the cloud?
So the question is, do you still have the need to use deployment server in the cloud? It depends on what you're ingesting. So today, what Firehose gives you is, let's say you move to Firehose, it gives you that native capability for data ingestion of CloudWatch logs, CloudWatch events, and AWS IoT. However, you would still, if for data sources that live outside of these services, you might want to realize that you would need the forwarder, and you would still need the deployment server to manage those forwarder. Yeah.
Would that be a deployment server service in AWS? To configure provision deployment servers, create the server classes, deployment apps?
Yes. So, but I'm not sure I follow. You're talking about deployment service of.
You don't have one yet, but
Yeah.
is that something that could be available through Amazon to provide that, or do we have to use the APIs that you guys provide? Or is that going to be somehow melded with Amazon Web Services, right? Just as a service?
Yeah, for now it is not the case, but I think that that's something that we could look into. And we can take this offline because we probably have the right person for this roadmap question. That you, I guess, right?
Yeah, go ahead.
Just a new feature in GovCloud.
So the question is this new feature available in GovCloud? The short answer is no today. Today, Kinesis Firehose is available in 6 regions: US East 1, US West 2, Dub, Frankfurt, Tokyo, and Ohio. But we do have plan to expand it to all the AWS regions next year, so it should be available fairly soon.
So the question is about what about the AWS TA? And I think I had the similar slide to address your question. For some reason, we removed it from the deck. But short answer, the TA is still there. You'd still need it for the services that are not necessarily supported out of the box today by Firehose. So one good example of this is S3. So today, for you to ingest the data from S3, you could use the AWS TA. And also, there are other AWS APIs that we integrate with that the TA has the native capability to ingest the data from these APIs. So you still need the TA for those APIs. And also, if you're talking reliability, if you remember one of the slide I have is when Firehose streams the data and persists it to S3 in case Splunk is not reachable, you might want to ingest that data back from S3 using the TA. So that's one option also, to have a push-pull type of architecture.
So the question is, do I need one Firehose for each of the index? So as I mentioned, Firehose use Splunk's HEC token to ingest data. And when you enable the token, you can specify default index along with the token. So all the data coming into that token will be indexed into a particular index. However, you can actually use Firehose Lambda transformation feature to override the index metadata of each of the records. So you can actually enable routing feature that way. So within Firehose, depending on the type of event you have, you can actually assign a metadata called index equals to A if this is this type of event, and index B if it's type B of event. So when the HEC token receives that metadata in a particular JSON format, it'll parse and route it into different index. So you can actually achieve that using a single Firehose delivery stream, getting to multiple index in Splunk.
And same thing applies to any metadata on the Splunk side, whether it's source type, source, and index included.
Any other questions?